Okay, one last thing I'd like to go over with you for the test tomorrow on Chapter 17 is the following. Now, let me just close that for a minute. Okay, so I believe I have a pen here. Let me just see. I'd like to talk about the heating curve. So let me just change my pen. Sorry, still working out the glitches here. Okay, there's my pen. Okay. So I'd like to sketch how to do a heat calculation using the heating graph of water. Okay, this is similar to the quiz that you just took, and this is probably what we're going to be talking about tomorrow on the test. So I'd like you to review it. Let's see. Let's say we have a piece of ice, and we're going to say the starting temperature is, well, minus 20 degrees Celsius. Now, why did I put that there? Well, you need to really know what is happening on the heating graph of water. And on the y-axis, you have, well, temperature. And some very important things happen at 0 degrees Celsius and 100 degrees Celsius, called the normal freezing point and the normal boiling point of water. So if I have a piece of ice at negative 20 degrees, I can't actually melt it until it reaches 0 degrees. Then I could start to melt it, and I need the molar heat of fusion, and then I can heat the liquid. Once it's liquefied, first it's solid, 100% solid, and then it becomes a mixture. And the temperature holds at 0 degrees. And I need the molar heat of fusion. And then I can heat the liquid. Let's say I want to heat the liquid up to 60 degrees Celsius. Okay, I'm going to say it's about there, between 0 and 100. So this requires for you to do 3 calculations. I could number them: step 1, step 2, step 3. Of course, you'll be given a bunch of values and you'll be given a graph. So calculation 1 involves the solid ice coming up to 0 degrees. That's a change in temperature calculation, and the change in temperature from negative 20 to 0 degrees is 20 degrees. Well, that requires a Q calculation. The mass of the ice times C of the ice, you'll be given that value, times the change in temperature, which we're going to put in as 20 degrees. So you'll get a Q value for this portion of the graph. I can highlight it for you if you like, right here. So that's calculation 1, okay? It will be in joules. Calculation 2 requires using the molar heat of fusion. The molar heat of fusion is always used when your temperature is holding and you are melting or freezing. So let's set up calculation 2. What you need to do is take your grams of ice and divide it by 18, which is the molar mass. Now you have moles of ice, and now you can multiply it by the molar heat of fusion. Remember, it will always be given to you. It's usually in kilojoules per mole, so you will need to convert that to joules. Let's see, if it's kilojoules per mole, then you need to remember 1 kilojoule is 1,000 joules. Okay, so this answer will be in joules. The second step will be in joules. Let's look at the third step, which is a heating step. Once you've turned your solid into liquid, you can now heat it. Okay, you can heat it. 60 degrees is the temperature change. So that requires, for step 3, a Q equation again, but this time the mass of the ice hasn't changed, but now it's just liquid. And C of water is what you need to use, and the change in temperature is 60 degrees. Okay, what will you get? You will get a total number of joules. How do you get the total heat? You add all 3 steps. Okay, I hope that helps in doing a heat calculation for ice to water. Please review so that you do well tomorrow. Have a good night.